This is Mrs. Zappia with Lesson 4, Definition of Reflection and Basic Properties, Grade 8, Module 2. Student outcomes for this lesson. Students know the definition of reflection and perform reflections across a line using a transparency. Students show that reflections share some of the same fundamental properties with translations, that is to say, lines mapped to lines, angle and distance preserving motion, etc. Students know that reflections map parallel lines to parallel lines. Students know that for the reflection across a line L, then every point P, not on L, L is the bisector of the segment joining P to its reflected image, P'. For this lesson, you will need tracing paper, ruler, and a protractor. The essential question for this lesson is, what are the three basic properties of reflections? Take a moment and copy the directions to reflect a figure across line L. Step 1. Trace the line of reflection as well as the points being reflected. Step 2. Flip the tracing paper left to right. Step 3. Keep the vertical line and point Q lined up with the original. Step 4. Draw and label the reflected images.
Place your paper over the figure. Reflect the figure across line L by first tracing the line of reflection as well as the points being reflected. So I'm going to trace the line. Placing point Q, point A, and point P. Step 2, flip the tracing paper left to right. Step 3, keep the vertical line and point Q lined up with the original. Step 4, draw and label the reflected images. The reflection of A is right here. The reflection of P is right here. And the reflection of L is L because it is the line of reflection. Then we'll remove our tracing paper. You may need to darken your images and label them. Figure A is the original. The image is called A'. Figure P is the original. The reflected image is called P'. Q, since it is on the line of reflection, has not moved, so it is equal to Q'. And line L similarly has not moved, so it is equal to L'. If the figure does not move because it is on the line of reflection, you can call it the original figure L and Q.
Pause the video and complete exercise 1 and 2 below. Resume the video when you are ready. If you would prefer, you can copy the directions on the page and then just follow along and do the reflection with me. We're going to reflect triangle ABC and figure D across line L and label the reflected images. So our steps are the same as they were on the other page. Go ahead and copy those and then we will reflect the image.
I'm going to do triangle ABC first. So I slide my tracing paper up over the image. And I'm going to be using a pen this time because I've run out of tracing paper. So I am actually using a bounce dryer sheet for my tracing paper. So the first thing you want to do is go ahead and trace your line of reflection because that's what you're going to line it up with. Then trace your figure. Notice that point B is on the line of reflection. Then flip the tracing paper left to right. Keep the vertical line and point Q lined up with the original. Now there is no point Q on this one, but I made a point at the top. so that we would know how far to move the paper up and down. Alright, that looks pretty good. Then you simply trace your figure. And this is the reflected figure of triangle ABC. Remove the tracing paper, darken the figure if you need to, and label your image. So the top point is A on the figure, the top point on the image is called A prime. The far point on the triangle is called C on the figure. On the image it is called C prime. Point B on the figure and point B prime on the image. Notice that point B and point B prime are the same because it is on the line of reflection. Now we'll go ahead and we will reflect image D. So I'm just going to go ahead and put this back on the line of reflection. Then trace the line of reflection as well as the points being reflected. So I'm going to trace the figure. And flip it left to right. Line it back up with a line of reflection. And trace the image. Notice on the reflections that we did not need to take that extra step of reflecting or of flipping the tracing paper over and tracing the image before we translated it. So one less step this time. Alright, so let's go ahead and label that. This is our original figure and this is our image.
Part 2. Which figures were not moved to a new location on the plane under this transformation? Point B and line L were not moved to a new location. Example 2. Features of reflections across a vertical line. If we reflect across a vertical line L, right here, then the reflected image of a right pointing figure, such as T. When we reflect it across line L, then it will now be a left-facing figure. Similarly, the figure T, which is a right pointing arrow, when we reflect it across line L, it is no longer a right pointing arrow. Now it is a left pointing arrow. Observe that up and down do not change as the line in reflection across a vertical line. Also observe the horizontal figure T remains horizontal. This is similar to what a real mirror does. A line of reflection can be a line or any line in the plane. In this example, we look at a horizontal line of reflection. Let L be the horizontal line of reflection. Let point P be a point off of the line. L and T be the figure across the line of reflection. Just as before, if we trace everything on red on the transparency and reflect across the horizontal line of reflection, we see the image reflected in red as shown below. So again, here is our original, and then when we reflect that up and down, notice that it has moved up to down instead of left to right. This is reflecting above or below. Complete exercise 3 to 5 independently. We are going to reflect the images across line L. Label the reflected images. These are your steps. You can copy them if you would like to. And then if you're feeling comfortable, pause the video and do this reflection on your own. If you would prefer to follow along, we'll do it together.
First, I'm going to trace the line of reflection as well as the figure being reflected. So I'm going to go ahead and do the angle first. This is called angle ABC. That was step 1, trace the line of reflection as well as the figure being reflected. Step 2, flip the tracing paper left to right. Step 3, keep the vertical line and point Q lined up with the original. Draw and label the reflected image. Label. So the point up here, this will be A prime on the image. The vertex is B prime. And the other angle, or the other segment or ray, this is C prime. Notice that it is a mirror image of the original. All right, then we'll do figure I, the circle. So I don't need to retrace my line of reflection, it's already on there. Trace your figure and also trace the segment IJ. Step 2, flip the tracing paper left to right. Keep the vertical line and point Q lined up with the original. Step 4, draw and label the reflection. Remove your tracing paper. You may need to darken your image. The top part here, this is point J prime on the image, and this lower point is I prime on the image. Then part 4 says, answer the questions about the image above. Use a protractor to measure the reflected angle ABC. What do you notice? And notice this is the reflected A prime, B prime, C prime. In order to measure that, I'm going to need to extend the rays a bit. So just take a straight edge and extend your rays. The reason I'm extending them is because my protractor is large. And in order to read the protractor, the segments or the rays need to extend. So I'm going to go ahead and line that up. Call this the belly button, and I put that on the vertex. And you want to make sure that it is level with the ray and lined up over here as well. Then follow the ray, and it looks like, let's see, 60, 62, 4, 61, 62, 63, 64, 65, maybe about 66 to 67 degrees. Angle A prime, B prime, C prime. Let's move this up a bit. Is about 66 degrees. Use a ruler to measure the length of IJ and the length of the image of I prime, J prime after the reflection. What do you notice? Alright, so let's see here. Lining up the 0, it looks like it's a little bit less than half, so that would be 1, 2, 3, 4, 5, 6. So half, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, so that's the number 1 there. Let's move that over a bit then. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each one of these marks is a 16th. So we're going over to this one, 0, 1, 2, 3, 4, 5, 6. So this segment is 6/16 in length. Segment IJ is equal to 6/16. And you can simplify that if you'd like. Divide by the common factor of 2, and you get 3/8. Then let's measure segment I prime, J prime. So what do you think it will be? Do you think it will be more, less, equal? Line this up on the end. And we have 1, 2, 3, 4, 5, 6. So it is equal. 6/16 or 3/8. So what do you notice? Well, I noticed that the segment length is the same as the original segment length, and for the angles measured with the protractor, I noticed that the angle measure is the same.
So the angle measures are the same. And the segment lengths are the same. Number 5, reflect figure R and triangle EFG across line L. Label the reflected image. What I want you to notice on this figure is that our line of reflection is a horizontal line instead of a vertical line, but we will still follow the same procedures to reflect it.
Place your tracing paper over the figure. Trace the line of reflection, and you want to make sure and mark the end of the line of reflection. And also trace the figures that you're going to reflect. And let's just go ahead and trace both of them right now. So where would you expect figure R to go? And where would you expect figure BFG to go? So instead of reflecting these left to right, since we're reflecting over a horizontal light, we will reflect these and flip it up to down. So take your tracing paper, flip it over. Then you want to line up the line of reflection, and you want to make sure this point is over the original. So I'm going to slide it over just a bit there. And now trace your figure. Notice that our figure of our triangle, since it crossed the line of reflection originally, it also crosses the line of reflection on your image. So then remove your tracing paper and darken your image if you need to. Label your reflected images. The original was called figure R, so the reflected image is called R prime. Then the uppermost point here is F. Now it is the lowermost point, and it is F prime. This point is E, and this point is E prime. And this point was F on the original, and it is called, it is G on the original, and it is called G prime on the image. Darken your image if you need to. So notice that figure R, the top has become the bottom, and the bottom has become the top. Here, notice that the top of the triangle has become the bottom of the triangle when you flip it over your horizontal line.
As with the translation, a reflection has the same properties as a translation from Lesson 2. Precisely, line segments, angles, etc. are moved by a reflection by moving their exact replicas on the tracing paper to another part of the plane. Therefore, distances and degrees are preserved. So our first basic property of reflection is a reflection maps a line to a line, a ray to a ray, a segment to a segment, and an angle to an angle. A reflection preserves lengths of segments, and a reflection preserves measure of angles. The basic properties of reflections will be taken for granted in all subsequent discussions of geometry. Pause the video to complete the section below. Resume the video when you are ready. Using the following figure, describe the three basic properties in your own words. Example 4. A simple consequence of reflection 2 is that it gives a more precise description of the position of the reflected image of a point. First, line L is the line of reflection. Next, line L bisects P prime. Third, O is the midpoint of P prime. So when we're talking about P prime, this is the segment connecting point P and P prime. So again, L is the line of reflection. Line L bisects, which means it cuts this segment P prime exactly in half. O is the midpoint. OP and OP prime have the same length. Again, OP, which is the segment on the right, has the same length as OP prime on the left. A point on the line of reflection remains in the original position, so the reflection of point A is in the same location as point A. The measure of angle AOP, which is right here, is the same as the measure of angle AOP prime, which is right here. They are both 90 degrees. Use the picture to label the unnamed points. I will highlight them for you and then pause the video and label them. Alright, so this is called I prime, and the farthest point here is called K prime. On figure A, we have H and F, so over here this would be H prime and F prime. On this triangle up here, this is the original, so it would be matching up with J and J prime. Then over on the right side for angle ABC, this would be C prime. The vertex would be B prime, and the farther point here would be A prime. Okay, so we have named all of our unnamed points. Next, what is the measure of angle JKI? So JKI would be right here, JKI. And on the original, we have 31 degrees for J prime, K prime, I prime. So if this measure is 31 degrees, then this measure will also be 31 degrees. Then the next one, KIJ. KIJ would be right here, 28 degrees, and then KIJ would be right here, which will be 31 degrees as well. And angle ABC is right here, and it corresponds with angle A prime, B prime, C prime, and it will have the same measure, 150 degrees. So the angle measures are preserved. Oops, let's change that to a pen. So we have 150 degrees, 31 degrees, and then this angle was 28 degrees. What is the length of segment reflection FH and IJ, and how do you know? So FH, let's change to green. FH is right over here, and that is 4 units, and the reflection would be over here, and it will also be 4 units. Then IJ, find IJ. This is I prime J prime, which is 7 units. So IJ will also be 7 units. Go ahead and label those. And how do you know? Because angle or segment lengths are preserved. Number 9, what is the location of reflection D? So reflection D, well, D is right here. So when you reflected it, did it move? It's the same location because it is on a line of reflection. Remember that a point on the line of reflection will not move when the image is reflected. In this lesson, you have learned a reflection is another type of basic rigid motion. Reflections occur across lines. The line that you reflect across is called a line of reflection. Also, it could be vertical, horizontal, or on a diagonal. When a point P is joined to its reflection P', the line of reflection bisects the segment P'.